This is actually part 2 of our ionic bonding series. So we've talked about how bonds form. So the ionic bonds happen when those charged particles, those opposite charges, attract each other. And so it creates a compound. And a chemical formula is actually a notation that shows what elements a compound contains. And it shows you the ratio of the atoms or the ions. So it tells you exactly how many of each ion you have in the ionic compound. And the way that we do that is we actually use subscripts. Subscripts are the small numbers below in a formula that tell you how many of each element is present. If the subscript is not written, like if there's no number afterwards, then that means that it's 1. It's understood that that is 1. So here are some subscripts. So here are some examples for you. And as you can see, it tells you exactly how many of each thing there are. So here we know that there are 2 hydrogens and 1 oxygen. And here for sugar, we know that there are 6 carbons, 12 hydrogens, and 6 oxygens. Something to keep in mind when you guys are writing formulas, so see, for example, in a Cl, that capital letter indicates that that's a new element. If you see a lowercase, then you know that that corresponds to that. The sodium. So you have to make sure that your capital letters are capital and your lowercase letters are lowercase, because a capital letter indicates a new element. So you have to make sure that there is a difference between your capital letters and your lowercase letters. When we go to name these ions, we always start with the positive ion, that cation, which is always going to be our metal. So another way to write this is with your metal. This is your nonmetal. And so naming these things is very easy because the metal will retain its same name. So magnesium, sodium, potassium, all of those will be the same. And then for your negative ion, you just need to change the ending of it to IDE. So for example, if we're going to make a compound between magnesium and chlorine, our formula is MgCl2. But our name is magnesium chloride. It doesn't matter how many of each atom you have. The metal name will be the same, and then the nonmetal will be changed to IDE. So if you're going to do sodium bromide, sodium is the metal, so you would write the formula, so Na, and then it's plus. Bromine is a capital B, lowercase r, because that's in group 17 that also gets a minus. So plus 1, minus 1, those cancel to create 0. So your ratio is 1 to 1. Figure in your textbook on page 145. So if you guys would go ahead and pause the video, turn to page 145, and finish filling out the rest of the chart. Okay, so now that you're back, let's go ahead and go over the chart together. Let's go over the answers. Here we know that the metal is lithium. Lithium's oxidation number is +1. Oxygen's oxidation number is -2. That's why you had to have 2 lithiums to balance out the oxygen. The name of this, the metal name is always the same, so you just write lithium. And then instead of oxygen, you're actually going to change the ending to oxide, so it's lithium oxide. Here, magnesium and sulfur have a 1-to-1 ratio, so it's just MgS. And the name would be magnesium sulfide. Aluminum fluoride. Aluminum is +3. Fluorine is -1. So we know that in order to balance out that +3, we need 3 fluorines. Here we have potassium. And this 3 is actually a polyatomic ion, so those particles all stay together. And this polyatomic ion is called nitrate. So when you go to write the name, you keep the metal name exactly the same, so this would still be potassium. But instead of nitrate, now we're going to change the ending to IDE, so it's nitride. This NH4+ is also a polyatomic ion. This is ammonium, and this is chlorine. So your formula would be NH4Cl, because it's 1-to-1. And then, again, you would just keep the name the same. So this is ammonium. But instead of But instead of chlorine, it would be chloride. Okay, I hope that makes sense. What I would like for you guys to do right now is I would like for you to take the worksheet that we did today in class, and I would like for you to go ahead and name all of those compounds that you created with those partners in class. Thank you.